Hey guys, today's tutorial, which is on loops, is going to continue straight from last week's tutorial. So we're just going to jump right in. Okay, so there's a couple types of loops. There's two main kind of categories, I'd say. There's for loops and there's while loops, and there's a couple different variations of each. So just to start, we're going to use a for loop. Or no, let's actually use a while loop. While loops are slightly easier to understand because they are really simple. And I'm going to create a comment in here. And let's see, what are we going to put in here? We're going to do trace high. Okay, so the expression here that you want to put in, it's kind of like an if statement, but instead of doing it once, it does it every single time that this is true. So if you plugged in true, you're going to get an infinite loop. Let's check that out. Okay, it says high forever, and the box or the window actually never pops up because it's constantly going through this. You can exit out of infinite loops usually by pressing stop here. So if you ever get caught in one, you can do that. If not, you might have to open up Task Manager and go find your thing in here and end it, which is not fun. But thankfully, it's not a biggie. So what we're going to do is we're going to create var I, which is an int, and we're going to set it equal to 3. Okay? And then we're going to do while I is greater than 0, so that means 3, 2, and 1. If we did equal to 0, it would also include 1, which would make it go 4 times, but we want it to go 3 times. We're going to do this. Trace high. And then at the end, we're going to do I is equal to I minus 1. So we're going to subtract 1. And because I use the end button, I am going to have to do the start task manager. So I'm looking for first AS3 project, so we will do image name and press F. We're actually looking for Flash Player right here. And all you need to do is go under Processes, find the Flash Player, end the process, and then you can use it again. So as you can see down here, it traced high 3 times, which is exactly what we wanted it to do. Now, this last line right here can be rewritten a couple different ways. Alright, so right now we're subtracting 1. The same exact line of code can be done by doing I minus equals 1. Okay, minus equals means that it's relative. It will subtract 1 and assign it to I. So I minus 1 assigned to I. Bit weird, but it's also going to get weirder. So we're just going to run it to make sure that that works. You see that it does. Now, there's also the post decrement operator, which is I minus minus. This will subtract 1. There is also the pre-decrement. Pre-decrement. Right, which is minus minus I. It does the same exact thing. Not quite. So, what we can also do is we could just put it right up here. So I minus minus is greater than 0. Now, this will help us see what exactly is going on. Actually, you know what? No. Let's do it inside the trace. High. So we're going to put a space between there, and then do I minus minus. Okay? So you'll see that it goes 3, 2, 1. Okay? Doing the decrement at the end of a variable, aka post decrement, means that it'll do it after the line is executed. If you do it at the beginning, it'll read this before it does the line of code. So now we're going to see 2, 1, 0 instead of 3, 2, 1, because the computer gets this line and it says, "Hey, I'm going to trace." Oh wait, there's a decrement, a pre-decrement. Try saying that 5 times fast. And it will basically subtract 1 from the variable before it goes to the line. And then if you put it at the end, it says, "Oh, hey, I will do that after I've done everything else in the line." You can also do that with math. If you have like a long equation, post will get done afterwards, and pre will get done beforehand. So those are some nice things. It's definitely easier writing I minus minus than I is equal to I minus 1, or I minus equals 1, especially since you can put it in lines of code like this. And you can do math right there. And we didn't really cover it in the mathematics tutorial. I kind of blanked on it. But so there's I minus equals 1. There's also, as you can probably guess, plus equals 1, which also has plus plus and pre-increment. There's also multiply equal 1, which wouldn't do anything. Multiply equals 2 would make the number double every time. And then if you do divide equals 2, that would do it. And like you can plug in any number here, divided by equals 10, multiply equals 10, and it would do it relative to I. So you would multiply it and assign it in the same line of code. Otherwise, I mean, this right here is the same as I is equal to I times 10. There is no I times time or I divided. That doesn't quite make sense. Actually, come to think of it, that's the comment. So that, yeah, those don't quite work. It wouldn't really make sense anyway because it would be by 1, so you get the same exact number. But yeah, so this is your first loop right here, the while loop. So we will keep that there. Now, there's also the do keyword, which I've never seen anyone use, so I don't really see what the point of teaching it is, because it's just going to make our tutorial longer, and yeah. If you guys want to go extracurricular and do some extra credit, you can look up the do statement that's sometimes at the end. It's called a while do loop. Okay, so the next one is for, and for is very, very similar to the while loop, except it's got 3 parts instead of 1. So this right here, I is greater than 0, we're going to see in this, but we're going to use j this time. J, which is an int, is equal to 3, j is greater than 0, and j minus minus. Okay, so we're going to trace hello plus j. Okay, and as you can see, it does the exact same thing as this loop. So this loop has 3 parts up here. One part that happens outside, one that is the condition, it's called, which tests to see if this is true, whether or not it should loop again. And if this is not true, then it says, I'm not going to go through the loop, I'm going to go to the next line of code. And then we also decrement the variable I. Now, with for loops, it does this pretty much for you by itself. There is the starting expression, which basically initializes everything, so you're all ready to go. This gets called once before the loop starts. So the first time it gets to the for loop, it reads this, it says, hey, I'm going to do this. And then it's like, okay, I can begin now. So it checks to see if this is true. If this is true, it does this. It does everything inside the for loop. And then afterwards, it says, okay, now I need to do the third part at the end. And it's like, cool, went through a loop. And then it goes again, and it says, hey, is this true? Do this, and then do this. Is this true? Okay, do this, and then, once again, decrement. And since we're going 3 times, it'll go, hey, is this true? 0 is not greater than 0. 0 is equal to 0. So break out of the for loop and continue on. And that brings us to our next point. Let's say that you wanted to do something special. So let's say that if j is equal to 2, which is going to happen the second time, what you can do is you can do this break keyword, which I kind of just mentioned. Also, I need to close this. Cancel. Okay, so open broadcasting software, which is what I'm using to record. This is hogging all my system's memory. So if I is equal to 2, we're going to break, which is going to break out of the loop, which is what happens if this is false. And breaking out of a loop just means that it's going to stop doing the loop. So if we run this, it'll go 3, and then it'll go 2, and since it prints out 2, and then it sees that it's 2, it breaks, and it continues on. Now, if we put this afterwards, it would have even more of an effect, because even though it would go through when it's 2, it gets to this before it gets to the trace, which means it'll never print out. So there's all sorts of stuff that you can do with breaks. There's also another type of for loop, which is called for in. It's very similar to for each, which I think is implemented in ActionScript. But we will use for var p string in players. So we're going back to the array that we set up last time. So basically what we do is we say, hey, actually no. We need p array because each one of these is an array, okay? So what we can do is it'll go, okay, so we've got this players array, and we want to find every array inside of it. Now, if this one was a 0, we would have an issue. But we'll check that in a second. So we will do trace p. So it'll go for every single one of these arrays that is inside the array players, and it'll assign it to the variable p, which we can use. So, string to an unrelated type A. Shoot. Okay, I guess we do need to do string, and that kind of makes sense. No, this doesn't make any sense. It's doing 0, 1, and 2. Okay. So let's comment this out and do players 0 is equal to Mario, players 1 is equal to Luigi, players 2 is equal to Wario. As you can tell, I kind of do these off the top of my head. I kind of think about what we're going to do and then see where it takes us. Okay, so it's still doing 0, 1, and 2, which isn't good. Okay, so this is where our handy-dandy Google search comes into play. So you'll be doing this all the time when you're programming. So for in AS3. Okay, so for each var, or foo in bar. Okay, we don't even have to put this in here, actually. We can just do for var p in players. That probably won't change anything. Okay, so let's do... Oh, this is why. Okay, we do want to do for each. Okay, so for each var p in players is going to get what's called the key. And the key is what you put into the subscript right here. So for each p in players is going to trace 0, 1, and 2, because those are all the keys right here. Now, if we did for each var p in players, it will get each of the values. So key, value. If you do each, it gets the value. If you don't do each, it gets the key. So now we get it. Okay, so we can now delete this and uncomment that. And what it should do is it should trace each of our arrays. Cool. So now what we can do is we can do another for loop in here. So for var, we've already used I and j, so the next letter is k. Int is equal to 0. K is less than p dot, we need to assign this to an array first. P dot length k plus plus. Okay, so what we're doing here is we're going to set k equal to 0. We're going to loop while the value k is less than the length of the array, which is 2. So it'll do 0, 1, and then once it sets it to 2 with the post increment here, it'll say, hey, 2 is not less than 2, 2 is equal to 2, break out of it. So now what we can do is we can do trace p sub k. This is a bit confusing because we're not doing a for each here. We're just doing a for loop. So we might as well actually rename p the player, just to make a bit more sense. So player, or we could even call it player data if you wanted. So the first k would be the name, and then the second k, if that makes sense, would be the color. So now we've got that. Now, if you also wanted to do some interesting stuff with the array, you know that your array is always going to be like this, and you don't want to say, hey, I want to get the color, so I need to do players Mario, which is 0, and then red, which is the color, which is 1. You could also do private const, which means that it's a constant. You can never change this type of variable. Mario, which is an int, which is equal to 0. Private const Luigi, which is an int, which is equal to 0. And let's use Control D. Also, Luigi should not be 0, it should be 1. Okay. And then private const color, which is an int, which is equal to 1, and then let's Control D that and do the first one. Name, which is equal to 0. Okay, so that's if this were to always say the same. So if you wanted to get Mario's name, you could do, let's go way down here. Let's do trace Mario's name, comma, and then do players sub Mario sub name. Mario's name is Mario. So you could change that a bit, and I accidentally got a 5 in there, but yeah, oops. So that's loops for you. We also could have done this. We might as well. I will comment this out quick. And what we can do is for each var data, which is a string in this case, we could just leave it empty and then it'll do any type if there were numbers in there as well. But let's just do string in player. We could do trace data, and that'll do the same exact thing as our original for loop. So with programming, there's always different types of structures and loops and variables that you can use, different design patterns, and in today's lesson that really was brought to light. And you're probably thinking, well, when do I use each? When do I want to use a for each? When would I rather use a for loop? It all matters what you're trying to accomplish. If you need to know the number that it is in the array, you probably want to use this. If you don't care, you might just want to use a for each. It might make it simpler to type. Player sub k is a bit nastier to look at than data. So it all comes down to preference, what you need to use, and then also sometimes speed. For loops versus for each, because they run differently on the computer, they have slightly different speeds, and if you're going over 1 million things in an array every frame, you might want to pick one over the other because it'll speed up your program a bit. But you shouldn't have to worry about that unless you're doing some crazy stuff, which you're not yet. So later on, when you're doing stuff, you can always look it up. You know, speed of this versus speed of this is a while loop faster than a for loop. And yeah, let's do one last thing way up here. So while true is an infinite loop. How would you do an infinite loop with a for loop? Alright, now the for infinite loop looks really weird, okay? What you do is you put nothing in there. So The only thing that's really important is the middle here, okay? So the first one right here has nothing in it, so it doesn't care, okay? It's going to do nothing at the beginning. Now the middle has nothing, so it's always true. It's basically like putting a true here, which is kind of strange. It will not work if you just do while. It'll say, hey, you have nothing in there. And then the end doesn't matter either. And you could do this with any loop, really. You could do for var int equals 0, do nothing, and then I++, and then you could break in here, which is kind of interesting. So you could do for like that, and that's always something that just looks weird, but it's kind of cool to learn. And yeah. So the next tutorial that we will be doing will be looking at functions. So we'll be learning how to write our own functions like trace. I hope you enjoyed this tutorial, and we will catch you in the next tutorial video.